Alright, so last time you guys have been working on the natural base E and the log functions. And you've also been working on exponential functions, how to solve them, graph them. So today, your notes are notes 4-7. And we're going to be looking at transforming exponential and log functions. So the last time you guys worked on transformations, you looked at this, which is also over there on the board. And so you have the reflection across the x-axis, which is when it's a negative in front of the entire function. You have your vertical stretch or compression, which is when a number is multiplied by the function. You have your horizontal stress or compression, which is when a number is multiplied inside the function. You have your shift to the right and to the left, or your horizontal shift, which is when you add or subtract inside the function, and your shift up or down, or your vertical shift up or down, when you add or subtract outside of the function. So when you look at exponential functions and their transformations, they are pretty much, well, not pretty much, they are exactly the same thing. It's the exact same idea, nothing changes. So you still have the reflection across the x-axis, vertical stretch compression, horizontal stretch compression, the horizontal shift, and the vertical shift. So let's look at a couple of examples. So first we have this function right here. Can you guys tell me what the transformation would be for this? Well, first, what is the parent function?
Can you just go a little slower, please?
Okay.
Are you guys still writing the part?
Yeah, I'm still on the formula.
Just let me know when you guys are ready. You guys ready?
Yeah.
Okay, so what is the parent function for this first example?
Should it go up 5?
It will go up 5.
I will compress by -2.
By -2?
Yeah.
Would it reflect across the x-axis?
It will reflect
Yeah.
across the x-axis.
And,
So our parent function would be 2 to the x because we have an exponential function. So you'll have a shift up 5 units and you will reflect across the x-axis.
So when you know the x?
No, that's just your variable for your exponential function, for the parent function. Next example. What is the transformation for this?
down B.
Down 3, up 2. No.
No, what?
Down 3, across.
What?
Stretch by what?
I stretched by 4. And then down.
Stretch, are you sure it's a stretch?
Compress.
Compressed.
Why would
By
it be
how
compressed?
much?
Wait, why would it be
Not
compressed?
for
What? How do you know the difference?
I don't see the numbers. In all fairness to them, I should probably mention this, we mostly concentrated on the vertical stretch and compress, the multiplier on the front. We might have mentioned the horizontal a little bit, it was always opposite. So you wouldn't have known that, so to speak, this is the part A of the course. So you can just go ahead and let them know.
Okay, so when you multiply inside the parentheses with the x, it's always the opposite of what you do on the outside. So let's say the 4 was on the outside, it would be a stretch by 4. But since it's on the inside, it would be a compression by 1/4.
Okay.
So it's always the opposite of what's on the outside. So for this one, it would be a shift down 3 units and a horizontal compression by 1/4. So our last example for this one. What would be the transformation for this? Okay, well, let's look at what would be the parent function for this.
2x minus 2. 4. 2x minus 4.
What is it?
2x minus 2.
It would be 2 to the x. 2 to the x is your parent function. This would be a transformation.
The x minus 2 or just the minus 2?
Just the minus 2 is a transformation of the parent function.
So it's down 2 or when you left 2?
For this,
Yeah.
well, look at your notes, what you just wrote down. When it's inside, what is it?
Left 2. Left 2.
Okay, when it's inside,
The
It's the
parentheses, then
opposite.
it's left 2. Oh, right 2.
and then, what about this 3 right here?
It's stretched by 3.
Right. What kind of stretch? Vertical stretch by 3.
Kind of stretch.
Okay, so for log functions, same idea. It's the exact same idea. You still have the exact same transformations. Everything inside the parentheses is always opposite of everything else. Well, let me say everything inside the function is opposite of everything outside the function. Okay, so let's look at a couple examples. So we have log of 1/2 times x plus 2. So what would be our parent function for this one?
1/2 x.
Not 1/2 x. The parent function?
I thought it was within the parentheses.
The parent function that you're transforming from, it would be log x.
Why?
The only do it for 1/2, just get rid of it.
No, I mean, the parent function would be log x and the 1/2 is the transformation.
So the parent function is in black up there too?
Exactly. Yeah. The parent function would be what's in black for your the notes part,
Yeah.
that's your parent function. All
Would it be to the
the,
right 1/2? Is that what you're saying?
I'm sorry?
Would it be to the right by 1/2?
Not to the right.
It'll be
That's the opposite?
a compressed. It'll be a compressed by 1/2.
It would be what?
A stretch or compressed by 1/2.
Which one is it?
A stretch.
By what?
1/2.
By
Two.
2, yeah. And
No,
then,
no,
of course, the +2 would make that a what? What type of transformation?
Shift up.
Right. So you have a shift up 2 units and a horizontal stretch by 2. Okay, the next one, we have 3 times log of x. What is your apparent function?
Log x.
So then what would be our transformation?
Vertical.
The transformation,
Vertical
vertical by 3.
Vertical what by 3?
Stretch.
stretch. Well, how do you know if it's compressed?
How do you know if it's compressed?
Yeah.
Well, if it's on the outside and it's a fraction, it's a compression.
Oh, okay.
If it's on the inside and it's a fraction, it's a stretch. Because everything on the inside is opposite of the outside. And last one, we have 1/4 times the log of x plus 2.
A vertical stretch by 1/4 and left 2.
A vertical what?
Stretch.
Not forward and pressure.
Vertical compressed.
I did the exact same.
Left 2.
Okay.
Shift
Right.
up 2.
So you have a vertical compression by 1/4 and a shift to the left by 2. Okay, so something that you always want to remember is that the operations done inside the parentheses or inside the function is always opposite of the ones that are done outside the parentheses or outside the function. Does everybody have these?
Yeah.
So we're going to move on to graphing exponential functions.
Is it the same one?
Yeah. Okay, so, alright. Disregard that little cross out right there. I had a little malfunction with that.
So it's supposed to be there?
No, I meant to cross that out.
So just go to the 1 and then get rid of the 2?
Right.
Okay.
Alright, so we wanted
Is
to.
that an example?
Yeah, it's an example.
Okay.
Well, it's an example, but it's kind of
I think that was
shows.
a formula, but okay.
Wait, so you stop at 4 now?
Yeah, you don't put the 2. You stop at 1.
Go ahead.
So
Something on
if we wanted to graph this, what would we do?
Just keep plugging those numbers into
Plug
that.
negative 2 into that X up there on the screen.
Which one of the markers do I use?
The ones that are on the left.
Okay.
So the first one's 0.1
What?
is not the hit.
Oh, that's crap.
Okay.
I didn't know that was powered.
0.1.
You can have 0.1 or I have 1/9, which is the same.
I'd rather have.
Wait, why don't we do the decimals are easier to graph?
True, that is very true. So we have 0.1.
And the
Is that
next
what
one's
you got?
0.3.
It was 0.
That one's 1.
Okay. What's 1?
That's 3.
All right, so graphing this, we have x equals -2, 0.1, which would be about here, -1, 0.3.
Mr. So I just have a quick question. I'm still confused. Whenever we graph, like before, like when we started graphing, like on our homework and stuff, there was always 5 numbers in the x. How come there's only 4?
Yeah, well, I only got 4.
Because it's easier to graph. I didn't make a big enough graph, so I just put enough numbers so that it would fit on the graph.
So usually is there 5 numbers?
Yeah.
Oh.
Yeah, because the next one would have been 9.
So on our homework today, we'll have to put all 5 numbers.
All right, so when x is equal to 0, we have y equal to
I'm still
1.
confused.
And then when x is equal to 1, we have y equals 3. So if you connect the dots, you'll get this.
Thanks.
Whoa, wait a minute.
Hmm?
Mine ain't going down.
Oh,
Oh,
don't. You said, okay, it's going to be way easier than just to put 2 n to the 9. Or 2 9. 2 9.
All right, so if do you all have all of this?
Yeah.
Yes.
Okay, so let's say we wanted to graph the inverse. Now before, when you graph the inverse, you would change the the x to a y and the y to an x, and you would solve for the y, sorry. You can do that. It just takes a whole bunch of time and a lot of effort that you really don't want to do. So all you can do is just switch the values. So how here you have 1/9 or 0.1, 1/3 or 0.3. You still have 1, you still have 3. You just switch them to you switch the x values to the y values and vice versa.
Okay.
You get graphed or just write it down?
You will graph it.
Would you want us to make another graph, but graph on the same graph?
You can graph it on the same graph.
I graph on algebra.
All right, so if we graph the inverse, then x would equal 0.1, which would be about here, and then y is -2. X would equal 0.3, y is -1, x equals 1, y equals 0, x equals 3, and y equals 1. so that it should look like a mirror image of your original function. And another thing to keep in mind is that with the exponential functions, one side is always flat, so don't forget that. Everybody got this? Yeah.
How is 0.1 and 1 to the 9th the same thing? How, wouldn't it be 1 to the 10th?
Don't be so difficult.
Okay.
How
Well,
is-
all right. Never mind, forget my question. All right.
Okay, so you have those questions over there on the board, page 285, numbers 4, 9, 25, and 33 through 37.
All right.
The problems that tell you to write the asymptote, you can not worry about that, just do all the rest of it.
That's the stuff about that ABC.
Wait, so what are we doing?
Oh, no, actually. But I'm bad. 666, 667.
Maybe that's it.
Well, I would be good.
How many doubles you have? How many triples?
And then push your second.
Really?
Second.
What's the second?
Push second.
This is the indicator.
Let's see, now give you two the.
I got it.
What's mine?
Count. Yeah, like they, ours only still, and I grew because of I went the other way, and I made it.
Like he drew first?
Did you need the notes then? From yesterday, right? You want the notes from yesterday, right?
That's parent.
Which was the 4, 6.
Do you have any graphic?
Yeah, but I don't think it doesn't have to be like exact. So just the basic shape.
Wait, Miss Eason, how would we graph this?
285.
Yeah, that's completely different. Oh, 3 times 4 to the, okay, never mind.
Let's see, so I wasn't trying to be difficult.
This graphing and then an inverse on the chest. So, you know, and because you just there's no right and wrong number of X's that you pick, as long as you pick enough, it gives you a
No,
shape.
I was just confused. I wasn't trying to be difficult on her. I just didn't.
But she said the right thing, she just didn't put that last one because the graph she made didn't have 9.
So, are we technically supposed to? Oh my God, dude.
It would be not a bad idea to have more. Okay, it's never a bad idea. You can't have too many, let's just say that, okay?
Too many questions.
You can't have too few. If you don't have enough look, if you go to what your graph is, you need more points. So, how many graphs are we asked to do on that page?
And then whatever the grade is.
Alright.
Hey, Mr. Draper.
Yes. Are any of these around the blocks?
Table.
You lost by 6, dude. Yes, I do. Yes, I will.
We got it write the inverse too.
I ain't even know right there.
Hold on,
You
hold
need
on.
help finding that
Next
page.
part of school.
No, I was like 4 pages away.
Yeah.
One
Ground law.
75, 3 and 12.
No,
Yeah,
that's
so
right.
they have to make this.
They don't know.
This is
Because I was
the,
guys asked them one day what a bum, because like they, because I was coming out, and then they like,
read it,
And then like,
read it. What is it?
cause this one time someone parked so close to me, I had to have my car straight off until I was out. And like, almost in the
No. You have to put this in.
Oh, you not?
No.
All right. They might have that wrong number. 48.
Not doing it.
Yeah. I did it in my head before the calculator was smart enough. You got what? You get it, right? Okay, that's mine.
How long, y'all?
I did like 5 times.
Did someone get their car?
Well, we gotta write consensus.
Well, if people just get along.
Let's talk about this fire.
Oh, she's saying you never thought, I figured they would.
So what I'm doing, just this?
They know you're doing it,
Graphing and inverse. Yeah.
Is there any cameras on this?
Right now,
That's why I parked in the third park.
I park all the way in the back, like, back. Like, I'm like, awesome, should I recognize
No,
it?
someone took off my parking.
Yeah, you want to grab.
I know the car that did
Well,
that.
I'm just saying something.
They just put the air back on, it's screwed in, but.
Okay, so.
That's just red marks.
My car?
I mean, if it's red marks,
Where do you park usually?
I park in, like, directly next to the freshman, I go in through freshman and fourth.
no.
Like right there.
Okay, you know what a canal's parking